there's something called the second derivative test. What the second derivative test says is that if you have a point in which f prime of x, or I should say f prime of c is 0, if you have a value where f prime of c is 0, then you can make some determinations about whether it's a or I should say whether there exists a maximum or a minimum at that particular c value. And we can do that by looking into f double prime of c. Now, if f double prime of c is in an interval that is concave up, now remember f prime of c is 0, so it would be right there, concave up. If I'm going to be concave up where my derivative is 0, then what I have is a relative minimum. If f prime of c is equal to 0, and again, this only works for the value where c is 0, but f prime of c is, if it's equal to 0, and f double prime of c this time is less than 0, then we're talking about a value where we're concave down, and if your slope is 0, where you're concave down, then what do you have?
Relative max.
A relative maximum. Now, a lot of different things can happen if f prime of c is 0 and f double prime of c is 0. And this is actually where we say the test fails. Because I can't just tell anything by if f prime of c is 0 and f double prime of c is 0. We could have a few different things happening. We could have a situation where, and this is what tends to happen the majority of the time, we have nothing there. Notice how we change concavity at this point. Right here, we're concave down, we move to concave up. So f double prime here would be 0. F prime is also 0 here, but we'd have neither a maximum nor a minimum at this point. But just because this is true doesn't mean it's going to be neither. You could have a scenario where, and if you, and f of x equals x to the 4th does this. The second derivative at 0 is 0, and also the first derivative is 0 at 0. But this is obviously a minimum value, right?
Mm-hmm.
So you could have a relative minimum. Or, if we just change it up and go to negative x to the 4th, we would have a relative maximum at that point. So, if the first and second derivatives are 0, the test just fails because it could be neither, it could be a relative min, it could be a relative max. All of those different things can exist there. So, let's do a problem involving this. AJ, if you had a problem writing this down, you can always pause the video and go back and write it down. All right, now, Let's take and I'm going to do an example here. F of x equals negative 3x squared. No, 3x to the fifth. Plus 5x squared. No, 5x cubed. Plus 5x cubed. Okay. So, I want to do the second derivative test on this one. So the very first thing I'm going to do is get the first derivative and set the first derivative equal to 0 to find my potential relative minimums and relative maximums. But they will be my critical numbers. So I get negative 15x to the fourth plus 15x squared, right? And from that, set equal to 0, I can factor out a negative 15x squared. And I would be left with x squared minus 1. So I get x equals 0, x equals 1, and x equals negative 1. Now these are my potential critical numbers. So now let's jump into f double prime of x, which would be negative 60x cubed plus 30x. Are we still okay?
Yeah.
All right, so I'm going to factor out a negative 30x, and I'll be left with 2x squared minus 1. So x equals 0, x equals plus or minus the square root of 1/2. Now I didn't really have to do that. I don't know why I did. Because all I really have to do is take the second derivative and plug these numbers in. So what is f double prime of 0? Zero. Okay. So the test fails at 0. Okay. All right. What is f double prime of 1?
Negative 30.
Okay, so it's negative 30. But more than that, it's negative, so we are concave down. So what do we have at 1? If our slope is 0 and we're in an interval that's concave down,
We have a relative max.
relative maximum, okay? And to find out what that value is, plug in 1. It would be 1. This would be negative 3 plus 5, so 2. So we have a relative maximum at 1, 2. Are we okay with that?
Yes.
All right, now let's go about negative 1. So f double prime of negative 1 is what?
30.
Positive 30? Yep. Okay. So that's greater than 0. Therefore, we are concave up. I don't know. I'll get it. I'll get it. So we're concave up there. So based on that, what do we know we have at negative 1?
Relative minimum.
Okay. All right, thank you. Hold on just a minute for you. Unless you're Okay, so we've got a relative minimum there, and if we plug it in, we get, I think, -2 is the solution. So it's -1, -2 is the relative minimum.
Wait, what does that even say?
All right. So that is a good example of a second derivative test problem.